This video is to help you learn about simple and compound interest. You can go to Canvas, and under Unit 6, there's a document here that has all of the notes that we're going through. I made a paper that only has the questions, so if you want that, all those notes you can, or you can open the book URL. And this is the PowerPoint that will go along with the video that I'm making. So I'm going to actually running this PowerPoint. Okay, so let's talk about some things here. If you use the PowerPoint, make sure that you pause it and work things out as you go, or you'll get confused. So first things first, finish your assignment from Tuesday, Wednesday. Grade the sub, or I will have the mark scheme. Go fast. Just look for the big stuff. Don't spend it like we're doing apps. See what questions you have. I'll try to answer them when I come back. And then you're going to play this PowerPoint and work out the problems as you go. The answers are at the back. See how many you can get through here. It will take you the whole period to get through most of these problems, and the answers are at the back. Check. This TVM solver is something you want to try to learn how to use today. Okay. So right now, if you want to find this on your formula sheet, you can, or just look at it. This is a formula for compound interest that we will be using. And so again, the terms are important. And all of these, if you have a TI-84, and most TI-83s have the TVM solver. If not, you're going to have to plug in values and learn how to use some other things to solve. Okay, so this is the information about interest and how interest is figured. Most of you think about interest as the principal times the rate times the time. That is true, but usually in the real world, most interest is compounded. So it's figured out, and then an interest on the interest and interest on the interest. And so that's what these formulas are. And they end up being a geometric sequence. Just like a 10% increase in pay, R value is 1.1. The same thing is true with compound interest, depending on how you compound it. Okay, you can pause and finish reading this. And this works also for financing and those kinds of things on the positive side and the negative side. Okay. So if you think about it this way, if your value of $1,000, 1 year is times 1.1, 2 years is times 1.1 squared, 3 years, etc. The first term is 1,000. The common ratio is 1.1. So you can come up with a formula for any term. Notice this is not n minus 1. So after 1 year, you would have 1,000 times 1.1 to the n, not n minus 1. Now, where this works is PV stands for present value, the amount you invest, 1 plus the rate divided by 100. So in other words, it changes the rate to a decimal. So make sure you don't change it to a decimal first. So 5% would just go 5 right there. Don't write it as 0.05 or scrap the 100. And then n is the number of years. This is pretty simple. This is yearly compound interest. Let's move this. You see, though, there's this little K right here. So interest can be compounded more than yearly. We'll do the year examples first. They're the fastest ones. So you just plug it in the formula. The rate is 7. Find the number of years. You can just type this in your calculator and find it. Notice parentheses. You can either change this to 1.07 or make sure you put parentheses in the right places. Make sure you punch the numbers, see if you get this. The compounding periods can change. If we're talking about yearly interest, K is 1. We're talking about half or quarter, or however many times a year. There's a bank in Fort Wayne that used to advertise daily interest, and they refigured it every day. The difference is your interest rate gets smaller if you have daily interest. The power gets bigger, but this also gets smaller. So it's not that big of a difference, but it definitely, if you're talking about the same rate, the more compoundings are, the better you're going to get. Okay, so interest is compounded quarterly. So K would be 2. So there's 8 quarterly periods. So 2 years times 4 quarters, it's compounded 8 times. But again, you can just plug it in your formula to get an amount. Okay, we don't need to use our solver for that. Okay, and sometimes they're going to ask you about the interest earned, and sometimes they're going to ask you the final balance. The interest is always the final balance minus what you started with. To me, that's kind of just common sense. So this one says how much interest is earned. So you'd figure out the ending amount, and then you'd subtract what you started with. So the ending amount is the present value, 8,800, 1 plus 4.5 divided by 1,200, because K is 12. But notice it raises it to the 42nd. So you end up with 10,298.08. It doesn't ask you for the ending amount. It asks for the interest. So just be careful you're answering the question when you're done. If you show your work, you only miss 1 point on those things. So the actual interest earned would be $14.98. And you got pounds there. So F.1, number 6, do that one together with the partner. You should be working together anyway. Pause the video, work it out, see if you know what you're doing, and we'll check the answers. So again, this is the greatest. Which one is the greatest for his inheritance? It'd be A. So A is the highest rate and still compounded yearly. So you notice just because you have more compoundings doesn't mean you make more money. Okay, so you're going to do the rest of 5F. You can stop and do those right now, or you can keep working and go back later. Check the answers as you go. So now we're going to use the TVM solver on your calculator. So under apps, there's a finance app. For some of you, it'll say finance. Some of you might just have TVM solver. It depends on your calculator. You want to open it up. I don't know if anybody has an Inspire. If you do, you got to find the finance solver. And basically, the thing you got to make sure you know how to do is the number of compoundings. So N times K is our compoundings. Present value, notice it says put it in as a negative. Input a 0. If you're not making payments, put a 0 there. These are the same. PY and CY are going to be the same. Number of compoundings you get from the problem. We're gonna do our payments at the end of the time periods. Okay, so she has 15,000 invested, compounded monthly. How much is her investment worth after 5 years? So using your TVM solver, you open it up. This is the stuff that you enter. And I'm going to pull this up here on the calculator and put it in so you can see it. So I go to apps, finance, and I'm going to enter 60 compoundings. Oops. Sorry, it's the first time trying this method. I'm approaching my free recording limit. I'm going to pause and pick it up later on. So you have to start the second video.